Okay, good afternoon, everyone. Welcome to this my YouTube channel. My name is Baragem Baradu. Thank you for being part of us today on this online tutorial. Today, before we look into what is before us, I would like you to subscribe to this YouTube channel if you have not done so, and then also like the video, share it with your friends, and even on your school platform. Thank you very much. Now, let's go straight to the point. Today, we are looking at separable differential equation. We are looking at separable differential equation. What is separable differential equation? As you look at the word separable differential equation, a separable differential equation is a differential equation that can be written in the form dy over the x equals to f of x all over g of f and g of y rather. That is a separable differential equation. I say that a separable differential equation is a differential equation that can be written in the form dy over the x equals to f of x all over g of y. For proper understanding, our f of x and our g of y are function of x and y. Are function of what? X and y. So let's look at example. So for proper understanding, let's look at example 1. Example 1, we have dy over the x equals to y all over equals to x all over y. This is our example 1. We should solve this example 1. Dy over the x equals to x all over y. And in this case now, we see that our f of x, that was the denominator, is now what? X. And our g of y, which was the denominator, is now what? Y. So let's take note of that. Now let's look at this. Dy over the x equals to x all over y. And this equation now is not being separate. You need to separate it for proper evaluation. So for us to separate this equation of dy over the x equals to x all over y, we do what? We cross multiply. We cross multiply by keeping all the value of y on the left hand side and all the value of x on the right hand side. So when we cross multiply, dy times y is going to give us what? It's going to give us y times dy equals to, when we cross multiply the x times x, it's going to give us what? X dx. So after having this y dy equals to x dx, now we have already separated them already. So what we are going to do next is to do what? Integrate both sides. Integrate our left hand side and integrate on our right hand side. And for us to integrate this, we integrate y and we integrate y with respect to y and integrate x with respect to what? Dx. So in this case, when we integrate y, you know that in integration, this y now have an invisible power of what? 1. And in integration, we're doing what? We're adding 1. So because this have an invisible power of 1, we add plus 1 all over what? The same thing we have on this upper side is going to divide by the same number. We have what? 1 plus 1 divided by 1 plus 1 also. Then plus c. You know that in integration we do what? We added plus c. So that's why I add plus c here. Then on the right hand side we have our x. For us to integrate this x now, x have an invisible power of 1, so we are adding by 1. So we have 1 plus 1, and then we divide by the same thing we have on this power, which is 1 plus 1. Then we add with what? Plus what? C also, which is our what? Constant 2. This c now is for our constant 2, and this is our constant 1. So take note of it. So in this case, after having this now, you know that y 1 plus 1 is 2. Then we have what? Y square all over 2 plus c. On the right hand side we have s square all over 2 plus c. So 1 all over 2, you just factor this number at 1 all over 2 times y square, the same thing as s square all over what? 2. So don't be confused about it. Plus c1 equals to what? 1 all over 2 x square plus c2. Here we also factor this thing out, because if you say 1 times s squared, it's going to give you the same thing, s squared all over 2. So it's the same thing. Since c1, since c equals to c2 minus c1, that is our c. Then we have 1 all over 2 y square plus c1 equals to 1 over 2 times s square plus c2, because that is what we have initially. So in this case now, you know that our c1 and c2, you know that our c, constant capital C, is the same thing as c2 minus c1. So in this case, we make 1 all over 2 times y square, which was on our left hand side, equals to 1 all over 2 s square, which was on our right hand side, plus c, because we just factor the c1 and c2 out. That's why I have this capital C here. So now this is the answer that we are gotten here. For us to find the value of y, what we are going to do now, we multiply both sides by what? By 2. So because this 1 all over 2 and 1 all over 2 is common on both the left hand side and the right hand side, so we are going to multiply both sides by 2. And when we multiply both sides by 2, we are going to have 2 all over 2 here, because 2 times 1 is 2 all over the 2 on the left hand side. Then on the right hand side, 2 times 1 all over 2 is going to give us 2 all over 2. So 2 all over 2 is going to give us 1. And 1 times this y square is going to give us the same thing, y square. And on the right hand side, we are going to have 2 all over 2 divided by 2 all over 2 divided by each other is going to give us 1. And 1 times s square is going to give us the same thing as s square, plus, because we are multiplying both sides by 2, we have 2 times this constant, which is going to give us 2c. So in this case, we are having y square equals to s square plus 2c. What we are going to do next is that we square both sides to eliminate this square on this y, because we want to make this y the subject of the formula in this particular equation. So as we want to make y the subject of the formula in this equation, we square both sides. And when we square both sides, we square the y square, then we square the on our right hand side, which is s square plus 2c. So this square root sign, this square will cancel this square root sign, remain what? Y. So our y become equals to square root of s square plus 2c. And we know that since 2 and c is a constant in differentiation or in calculus, we make this 2 and c become what? This capital C, for proper understanding. So our y now become what? Square root of s square plus c, and this is our final answer. So take note of the solving. Thank you very much. Now let's look at the second example. Okay, before we look at this second example, please, if you are new here or you have not subscribed to this YouTube channel, please, I beg of you, kindly subscribe to this YouTube channel, because this is the only thing that will encourage you to do more on this online tutorial. And to subscribe to this channel, they are not going to charge you any money. It's just like a token of helping us and also make things more easier, because anytime we uploaded new video, you'll be able to get more access to the video. So if you are not subscribed, kindly subscribe to this YouTube channel. Before we look at this example 2, thank you very much. Please pay attention to this second example. Now let's look at second example. They say we should solve the y over the x equals to x squared plus 1 all over y squared plus 1. This we need to use the separable method of differential equation to solve it, because we have the value of x and y interceding in this equation. So for us to solve this kind of question, what we are going to do here is that we have the y over the x equals to x squared plus 1 all over y squared plus 1. So for us to solve it, we put all the value all the value of y on the left hand side and all the value of x on the right hand side. That is the first step to do. So because of that, from this place now, we know that the y over the x equals to x squared plus 1 all over y squared plus 1. So what are we going to do now? We divide both sides by the x, so that the x will just go on our right hand side. So when we divide both sides by the x, we are going to leave with the y equals to what? Because this is dividing both sides by what? This is multiplying, sorry. It's multiplying both sides by the x. It's multiplying both sides by the x. When we cross multiply the x here, we are going to have the y equals to what? Equals to bracket x squared plus 1 all over y squared plus 1 that we have on the right hand side multiply by the x here. And when the x multiply this side, you know that the x will cancel the x. That is why we left here by what? The y. So now multiply both sides by what? This so in this case now we multiply both sides by what? Y square plus 1. And for us to make this y square plus 1 be on our left hand side, we multiply both sides by y square plus 1. So this y square plus 1 multiply this dx here, we have y square plus 1 times dy, times dy on our left hand side. Then we multiply y square plus 1 on our right hand side, all over x square plus 1 all over y square plus 1 that we have initially. So in this case now, this y square plus 1 we cancel this y square plus 1. So we are going to left with x square plus 1 dx in this place here, which is on our right hand side. So on our left hand side we are having y square plus 1 times dy. So we are now already separate both variable, both on the left hand side and on the right hand side. Now what we are going to do now is to integrate both sides, because now they are in their right parameter. Y is on the left hand side and x is on the right hand side. So now you need to integrate both sides with respect to their right parameter. So we have y square plus 1, we integrate with respect to y, respect to dy. So when you integrate this with respect to dy, you know that y square plus 1 is the same thing as what? Y square, integral of y square plus integral of 1. In this case, we have x square plus 1. The integral of x square plus 1 is the same thing as the integral of x square with respect to the x plus the integral of 1 with respect to the x. So now we integrate them what? Separately. So if we integrate y square plus, if we integrate y square, we're going to have what? We're adding 1. So 2 raised to power, y raised to power of 2, we add plus 1, because in integration we're adding 1. So we have 2 plus 1 at the upper power, then we divide 2 plus 1 also, plus this our 1 now. When we integrate 1 with respect to dy, we are going to have what? Y. That is it, because it's a constant. This 1 is a constant. So when we integrate a constant in integration, we integrate it with respect to the integration, which if it's respect to x, it become what? X. But if it's respect to the y, it become what? Y. So when we are integrating this 1 with respect to y, it become what? Y. So in this case, we have y plus c1. Then on the right hand side, we integrate x square. We have what? X square plus 1 all over 2 plus 1, plus when we integrate this 1 with respect to the x, the constant become what? X, plus what? Our constant, which is our second constant, which is 2. So in this case now we're having y equals to what? 3 all over 3, because 2 plus 1 is what? 3. All over 2 plus 1 here is also 3, plus our y plus our constant 1, which is c1, then equals to x cubed all over 3, because 2 plus 1 here is what? 3, all over 3 here, plus our x plus our second constant. So in this case, we are having what? 1 all over 3, because 1 all over 3 times y raised to the power of 3 is the same thing as y raised to the power of 3 all over 3. We just bring it, this constant, to multiply it like that, but it's the same thing, plus y plus our constant 1 equals to 1 all over 3. We factor it out also, just bring it out also, times x raised to the power of 3, which is the same thing as x cubed all over 3, plus x plus c2. So in this case now, we know that since our c is the same thing as c2 minus c1, then we just make the c, that the c1 on the left hand side, to be on our right hand side by having them as our capital C. So therefore our final answer become 1 all over 3 y raised to the power of 3 plus y equals to 1 all over 3 x to the power of 3 plus x plus c. So this is the final answer. If you have any question concerning this separable differential equation today that we just studied, you can drop it in the comment section. And please, if you are not subscribed to this YouTube channel, kindly do so, so that we can work hand together and get the best out of our study. God bless you all. Thank you.